Hey Calculus, welcome to our first video lecture of the semester. This is what they look like, me and a map and usually some of my kids' crap that's been left behind in this room. Today we got Baby Yoda looking over my shoulder. And I would encourage you in these videos, rather than just sitting back and just watching the videos, to take the time to take some notes as things go along. What your hand writes, your brain has an easier time remembering. So just by taking notes, you're kind of studying as you go along. Today, we're going to finish what we started talking about in section 2.2 on the limit of a function. And here I have graphed one of those piecewise functions I was talking about. If you have no idea the connection between the function over on the left and the graph over on the right, I'd really encourage you to go back and look at those pre-calculus review videos I posted over graphing piecewise functions. So this is the function f of x, where it's 2x plus 1, the line over on the left, as long as x is less than or equal to -1, and 5 minus x squared, that downward opening parabola, but only for x greater than -1. So we'll just do a couple of limits to remind ourselves of what we were talking about at the end of our last class. So first, we're asked to evaluate the limit of f of x as x approaches 1. And remember how we were doing this. We were covering up what was happening to this function at x is equal to 1. So I'm going to cover up what's going on at x equals 1. I'm going to draw my little vertical line there just to kind of blur out what's going on. And if we don't see what's going on behind the scenes, it looks like the y coordinate is going to be equal to 4. So we're going to say the limit as x approaches 1 of f of x is equal to 4. And never mind that it actually does achieve a y value of 4 at x equals 1. Remember, the limit only cares about what's going on very, very close by to x equals 1, not actually what's going on at x equals 1. Same function, let's look at limit as x approaches -2 this time. So I'm going to go find x equals -2 on my x-axis and draw down that vertical sort of curtain, hiding what's going on at x equals -2. And we just look at what's going on nearby. So it looks nearby like we're headed for a y coordinate of -3. So we're going to say that the limit as x approaches -2 of f of x is -3. So the more interesting limit to talk about for this function is the one at -1. This is where all of the piecewise action happens, where we cut the two functions in half and sort of Frankenstein them together there at x equals -1. So when we go to take a look at the limit as x approaches 1, we're going to draw our little curtain here at x equals -1. So we no longer see the open circle or the filled in circle, and we're just trying to say, what does it look like the y coordinate is going to be? And it kind of matters which side of -1 you're on. So if I'm on the left-hand side and I'm traveling along the linear function, it looks like I'm headed towards a y coordinate of -1. But over on the right-hand side, if I'm traveling along that parabola, getting closer and closer to -1, it looks like the y coordinate is going to be a +4. So the left half of this function wants the y coordinate to be -1. The right half wants it to be a +4. So what's the answer? What is the limit equal to? Well, because they don't agree, we're going to say that this limit does not exist. Okay, so it does not exist. Sometimes we use the abbreviation DNE for that, or you could say that this limit is undefined. It has no value. So we do want to have a way to communicate that this function has two different things going on either side of -1, and that's the reason why the limit doesn't exist. So I'm going to introduce a new notation here. So I'm going to say that the limit as x approaches -1, and I'm going to put a little negative superscript up there like it's an exponent. And what that's going to indicate is that we're talking about the negative side of -1, meaning the left-hand side of -1. And we're going to read this as the limit as x approaches -1 from the left. So from the left, the limit of f of x is equal to -1. And again, we're saying from the left. And that's what that little superscript negative sign means. And then we're going to do the same thing, but from the right-hand side. So we're going to say that the limit as x approaches -1 from the right-hand side of f of x, so I'm putting a little plus superscript there above the -1, that one's going to be equal to 4. And we'll say that's the limit from the right-hand side. So this is a way to acknowledge that the y coordinates are approaching a value, but only from that one side. And then from this notation, we can also see that they don't agree. So the overall limit, we're going to say, does not exist. So here I have that notation sort of officially defined for us. I have the limit as x approaches a with the little negative superscript of f of x equals L, means that f of x gets close to L as x gets close to a from the left. So again, that little negative symbol up here is what indicates that we're talking about the left-hand side of that x value. And again, the L, what the function is equal to, this is the y value, the y coordinate that you're getting closer and closer to. And then if I put that positive superscript on the A, the limit as x approaches A from the right, that's what this positive superscript means. That indicates from the right. That means that f of x, or the y values, are getting closer to L. So those are our y coordinates. Okay, so f of x gets close to L as x gets close to A, but only from the right-hand side. All right, and then our theorem here says that the overall limit, if we're going to write x approaches A, not with a plus or a minus superscript, but the overall limit is equal to L if and only if the left-hand limit and the right-hand limit agree. So our left-hand limit and our right-hand limit, those have to agree. Otherwise, we're going to say that the overall limit at x equals A does not exist.